some more power series. So for these, we're going to find the radius of convergence and the interval of convergence. So and all these, I think the next couple examples, they're all around x equals some a, not x equals 0. It's a little more complicated, but we're doing the same thing. We're doing this. Okay, so I put that in here. I got absolute values of the n plus first term. We have 5 to the n plus 1, n plus 1 to the 5, and then 1 over the n, so 5 to the n to the 5 over x plus 4 to the x. Okay? Again, as I pull in my absolute values, the only thing that I can have really is this x plus 4 term. Now you want to be careful here. You want these parentheses to be your absolute values. It's not absolute value of x plus 4. It's absolute value of the whole thing x plus 4 because that's what goes to the power of n. Okay, so this is, when you pull them in, you want to pull it there, thinking of that whole thing as the term. So this kills that. This kills that. Now I'm going to rewrite it a little bit. I've got x plus 4 left. I've got a 5 down here. And then I've got n to the 5 over n plus 1 to the 5. Okay, so we'll take a limit of this. I should have written out x plus 4 over 5 4, but that's okay. I can put all these under the 5 if I want. It's a little bit easier than working out the n plus 1 to the 5. But what's going to happen is, of course, this whole thing is going to go to 1. And I'm going to end up with absolute value of x plus 4 over 5 is less than 1. Okay? So I want to work that out. I'm going to multiply both sides by 5, right? So my answer then is x plus 4 is less than 5. So 5 is my radius of convergence. Okay. I'm centered at -4, right? Because it's x minus it. So if I think about this, it's really, this is equal to 0 at x equals -4. So when I have something like this with x minus it, I think about when is this going to equal 0? It's equal 0 at -4. So I have this centered around x equals -4. All right, so let's work that out. Let me just show you, though, how I work that out, because this gets a little bit maybe confusing sometimes. So if I've got this, absolute value of x plus 4 is less than 5, that means this, right? Quantity x plus 4 is between -5 and 5, right? I just subtract 4 from both sides and the middle, okay? So my radius of convergence is 5. My point at the center is x equals -4. So if I draw this guy here, I have to go 5 around it, right? Okay, so here's 0. Doesn't matter. But we add that. Okay, and I'm able to do that. I mean, I don't have to really worry about that. I just do it from here, just working out these absolute values. When I have absolute value of something less than whatever, it's just minus and then plus, right? That's all you're doing. Magically works out, right? Magically. By math. So I've done with my question about the radius of convergence. The radius of convergence is 5. Is 5. If they're also asking for the interval of convergence, though, I need to test my endpoints. My endpoints here are -9 and 1. Okay? So if I'm going to check the endpoints, I'm going to put in, say, x equals -9, right? Put that into my thing here. I've got -9 plus 4 to the n over 5 to the n to the 5. So I've got -5 to the n here, and this 5 to the n to the 5. Oh. Okay. So this is going to be -1 to the n over n to the 5. Well, this converges, right? In fact, it converges by the alternate series test, but you could also say it converges absolutely because it's a p series of p greater than 1, so if it converges absolutely, it converges. So either way you want to do that, you're going to get that it converges there. Now my other endpoint is x equals 1. Then I'm going to get 1 plus 4 to the n over 5 to the n to the 5. So I've got 5 and 5. Lots of 5s, n to the 5. And here I'm going to get something that also is convergent because it's 1 over n to the 5 series convergence. So this one converges at both endpoints. So they're both closed circles there. So my interval of convergence, which I can now happily say converges at both endpoints, is this. Okay? And we know that it diverges outside of that. So if I put in -9.1, I'm going to get a divergence series. So we're only going to check the endpoints because the endpoints is exactly where this thing is not clear. Okay. Let's see what else we have. Let's do another one. Okay. So this is going to be centered at x equals 1. Do my ratio test. Oh, 4 to the n over n. This guy. Okay. Pulling in my absolute values. And x minus 1 to the n. All right, there. So after simplification, I get n plus 1 times, x minus 1 in the top. And then at the bottom, I've got 4n here. I mean, some people like to just take out the x term, so I can do that. Minus is that you're only taking the limit with respect to the n stuff. So I can write it this way if I like. Okay? Now, this guy, if I've got n and I've got 4n, this guy's going to go to 1/4, right? So this is going to be x minus 1 over 4. I want to make that less than 1. So my radius of convergence is going to be 4. Right? So here, I'm going to rewrite it. I've got x minus 1 less than 4. So if all they ask you for the radius of convergence, then you're done. If they ask you for the interval of convergence, we have to figure out what interval that corresponds to and what the endpoints are, right? So let's do that. So I'm going to work this out. Minus 4 is less than x minus 1 is less than 4. Add 1 to everything. Going from minus 3 to 5. So here is my center at x equals 1. And we're going 4 from both sides. So far I have that. Now I need to check endpoints. I'm just going to write endpoints, and I'm going to check them over here. For x equals 3, we put that in there. And, oh, it's negative 3. Like, wait, what? Did you just see me a double take right there? All right, this is what happens when you write it down wrong. Nice double take. All right. Beautiful. Okay, so what we have here, just startling too much. It was too much. Okay, what we have here is going to be n times minus 1 to the n, 4 to the n, right, because it's minus 4 to the n, over 4 to the n. These guys cancel. So I've got well, this hopelessly diverges, right? Because this guy totally fails, right? This is not a decreasing series that goes to infinity as n goes to infinity. We have that n there. No good. Okay? And the other situation is going to be just as bad. Right? If I put in x equals 5, so I'm kind of stuck down here, but I'm going to have n times 5 minus 1 is 4, right? That's no good either. Also diverges. So here's the third case. So we've done all 3 cases with the interval of convergence. In one case, the first case we did, one of the endpoints worked and the other didn't. In this case, neither of the endpoints worked. So my interval of convergence is minus 3, 5. Neither minus 3 nor 5 is going to work. 3 works just fine. Okay? 3 is over here. I have another example to do, but I will do that in a separate video so these don't get too long.